Welcome to the Daily Vibe Casting. Today, Anthropic crosses the trillion-dollar threshold. NVIDIA plots a stealth takeover of the PC market, and the college degree might officially be dead.
Quite the lineup.
Yeah, it's massive. We're slicing through the noise of your hyper-accelerated feeds right now because if you don't understand how the rules of computational and, financial gravity are being rewritten today, you will be left completely behind tomorrow.
Right. And I mean, in a market moving at this velocity, the headlines are almost always a distraction from the structural reality.
Totally.
We're seeing massive capital flows and, frankly, terrifying technological leaps. But the actual story is hidden in the second-order effects.
The stuff in the fine print.
Exactly. We need to look at the mechanics of who is quietly cornering the hardware market, how regulatory frameworks are just mathematically failing, and what this all means for your own relevance in the workforce over the next 12 months.
So let's start with the absolute highest financial stakes on the board right now. There is a massive update circulating from @Polymarket.
Yeah, I saw this.
It's crazy. Anthropic's private valuation has officially blown past $1 trillion. We are looking at a $965 billion post-money valuation following a $65 billion raise.
That's just an astronomical amount of capital.
Right. And the underlying projection is staggering. Their annualized revenue run rate is slated to hit $47 billion by this month, May 2026.
See, we really need to view a $47 billion run rate with a heavy dose of skepticism.
You don't buy it.
Well, jumping from $14 billion to $47 billion in mere months suggests massive front-loaded enterprise adoption.
Like companies just buying giant blocks of compute up front.
Exactly. But a near trillion-dollar private valuation creates a very specific structural nightmare for a company.
How so?
Think about it. How do you retain the top-tier talent who actually build these models? Those engineers are sitting on millions in equity, but it's entirely illiquid.
Oh, right, because they aren't public.
Yeah, they can't buy a house with paper equity when the IPO market is practically frozen.
So they're trapped in this sort of golden cage. But wait, how do companies actually solve that without going public? Because I just saw Brett Adcock over at Adcock, Brett, announce that Figure AI completed a $100 million employee tender offer.
Right, and a tender offer is the exact mechanical solution to that golden cage.
Okay, break that down for me.
Sure. Instead of forcing engineers to wait for an IPO that might be, years away, the company or an outside investor steps in and offers to buy back a set portion of the employee's private shares for cold, hard cash right now.
So it acts as like an emergency pressure valve.
Exactly. Deep tech startups, especially in general-purpose robotics like Figure AI, have incredibly long horizons before they see massive public exits.
That makes sense.
If you want to keep the best engineers from jumping ship to publicly traded tech giants, where their stock options vest into liquid cash every quarter, you have to engineer your own liquidity events.
But I'm going to push back here because liquid cash isn't the only way these giant tech companies are trapping people.
What do you mean?
Well, in software, the ultimate retention tool isn't always the paycheck. It's the workflow friction.
Ecosystem lock-in.
Yes. There's a deeply telling post from @Kimenismus. They openly admit that Anthropic's new Opus 4.8 model is incredibly capable, like arguably the best in the world right now.
A lot of people are saying that.
Right, yet they're sticking entirely with OpenAI's GPT 5.5 and Codex.
Because of the integrations.
Exactly. The friction of ripping out their entire daily workflow just to switch to a slightly smarter model is just too high.
Which honestly completely validates OpenAI's current architectural strategy.
Right, because Thibault from OpenAI at the SOTU just clarified their versioning strategy. The jump from GPT 5.0 to 5.5 wasn't about raw, godlike reasoning improvements.
No, it was about speed.
Yeah, the entire focus was on token efficiency, which translates mechanically into speed gains. And they are already hitting internal checkpoints for 5.6. But surely, if a competitor builds a model with vastly superior logic, developers will eventually endure the friction of switching, right?
You would think so. But you have to look at the underlying economics of an API call.
Okay, walk me through that.
Token efficiency isn't just about the model replying faster. It means vastly lower compute cost per query.
Gotcha.
If a model costs a fraction of a cent to run rather than 5 cents, you can embed it into 1,000 tiny background processes in a developer's daily workflow.
Like checking spelling and auto-completing code.
Exactly. It formats your data, all silently. Once a developer builds their personal infrastructure around those cheap, fast API calls, ripping them out breaks their entire system. OpenAI is winning the retention war through economic gravity. not just raw IQ.
That makes total sense. The infrastructure just becomes a sticky trap. But while product cycles and capital are moving at the speed of light, our government oversight is practically standing still.
That's an understatement.
Yeah. We have a jarring update from @UnusualWhales. And just to be clear to you listening, we're looking strictly at the mechanics here, remaining entirely politically neutral. But former President Donald Trump was just fined $200 for being months late to report buying and selling hundreds of millions of dollars in stocks.
Hundreds of millions.
Yeah, we are talking massive trades involving Microsoft, Amazon, and NVIDIA.
We really have to look at the mechanics of this fine, stripping away the politics entirely, like you said. Under the Stock Act, top officials must report transactions over $1,000 within 45 days.
Okay.
The statutory penalty for missing that deadline is a flat $200. This is structurally meaningless.
Totally meaningless.
We're looking at a system where market activity exceeding 220 million to 750 million triggers a penalty equivalent to a decent dinner.
It's the equivalent of like a 1-cent parking ticket for a bank robbery getaway car. The math doesn't even compute.
It ceases to be a regulation. It becomes a minor administrative fee. It perfectly illustrates how the scale and velocity of modern capital have completely decoupled from the regulatory mechanisms designed in the last century to oversee them.
Wow, yeah. And if regulators cannot even track the basic stock trades of yesterday, they have absolutely no hope of regulating the physical hardware being built for tomorrow.
Definitely not.
Because the entire battlefield of AI is about to shift from the cloud directly into the laptop sitting on your desk, NVIDIA is executing a stealth takeover of the consumer PC market.
And they're hiding it plain sight.
They really are. At NVIDIA AI just dropped a highly cryptic post. It's just a set of coordinates 25.0528.121.5990 and the phrase, "a new era of PC."
I love when they do this kind of marketing.
Right. Poonam Soni at Code by Poonam broke this down brilliantly. Those coordinates point exactly to Taipei, precisely where the Computex hardware show starts on June 2.
The timing is perfect.
The signal here is that NVIDIA is launching an ARM-based system on chip built in partnership with MediaTek, integrating their Blackwell-derived GPUs directly into thin Windows laptops.
The implications for the entire hardware hierarchy are catastrophic for the incumbents.
You think so?
Oh, absolutely.
Yeah.
If you look at Intel and AMD, their entire dominance is built on the x86 architecture. And x86 is fundamentally power hungry. It requires massive cooling fans and just drains batteries.
Okay, I always hear these terms x86 versus ARM. Why exactly is x86 so power hungry compared to ARM? Like, what is the actual mechanical difference?
Think of x86 as a massive, complex instruction set. When it receives a task, it uses a very convoluted multi-step process that requires a lot of electrical power to execute.
Okay.
It's designed to handle incredibly complex legacy software. ARM architecture, which Apple uses for their incredibly efficient M-series chips, relies on a reduced instruction set.
So it's simpler.
Exactly. It breaks tasks down into much simpler, uniform chunks that process at lightning speed while sipping electricity.
So x86 is like carrying around an entire 50-pound mechanics toolkit everywhere you go, just in case you need it, while ARM is just having the exact lightweight tool you need exactly when you need it.
Precisely. NVIDIA is essentially telling the market, we're going to give Windows users the legendary battery life of an Apple MacBook, combined with the raw, localized AI computing power of an NVIDIA RTX 5070.
That is insane.
If they succeed, Intel, AMD, and Qualcomm are going to lose massive market share practically overnight.
But this introduces a massive question for you listening. What models are you actually going to run locally on these hyper-powerful new laptops? Right now, we are tracking a war between the massive proprietary cloud models and the local open source models.
Right.
At Impok A Research tracks this data meticulously. According to their capabilities index, open-weight models have lagged proprietary state-of-the-art models by a consistent 4 months since the start of the year.
That's a significant gap.
Mechanically, that's an 8-point gap on their scale, equivalent to the jump from GPT-5 to 5.5.
Yeah, a 4-month gap in AI development is an entire generation. But the consensus that open source is losing is flawed.
How so?
The open source community isn't trying to beat a trillion-dollar company like Anthropic on raw, godlike reasoning.
Yeah.
They know they can't win a compute spending war against private capital.
Okay, so what's their play?
Instead, they're entirely focused on a new metric, intelligence per watt. They're optimizing for hyper-efficiency.
And we are seeing that localized hyper-efficiency play out right now. Adolama just announced OpenJarvis, built by Stanford's Hazy Research Labs.
Oh, this is a fascinating project.
It really is. It's a local first personal AI that runs directly on your machine. It handles your morning briefings, organizes your calendar, and can literally execute local Python code on your device.
It is huge.
And then you have Jerry Liu at Jerry Liu showcasing Llama Index's Light Parse V2. They parse a highly complex 36-page PDF natively in the browser in 2.22 seconds.
Let's focus on that speed, 0.22 seconds.
My browser freezes if I open 10 tabs. How are they achieving native desktop processing speeds entirely inside a web browser?
By using WebAssembly and Rust. Historically, web browsers run on JavaScript, which is an interpreted language.
Right.
The browser has to read the code, translate it, and execute it on the fly, which causes that clunky bottleneck you experience.
Yeah, the spinning wheel of death.
Exactly. Rust is a hyper-efficient, memory-safe programming language. WebAssembly allows developers to take that Rust code and compile it down into a binary format that the browser can execute almost as fast as a native desktop application.
So instead of the browser constantly pausing to translate the instructions, WebAssembly hands the browser a pre-translated, perfectly optimized set of blueprints.
Exactly. And the second-order effect of this is profound. If you can process a 36-page PDF locally in 0.22 seconds, you have zero latency, zero API costs, and absolute data privacy because the document never leaves your machine. When NVIDIA's new ARM chips hit the market, hyper-efficient local agents like OpenJarvis will run flawlessly in the background all day, entirely untethered from the cloud.
But the moment you give an AI the ability to autonomously write and execute Python code on your local operating system, the security risks skyrocket. Like, if it hallucinates or gets hijacked by a malicious prompt, it could wipe your hard drive.
Which is why autonomy requires a localized immune system.
And the developer tools are adapting instantly to that. At Cursori, the popular coding platform, just launched auto review mode.
Yeah, this is a really smart feature.
Instead of forcing a human to manually approve every single command the AI wants to run, they built a dedicated classifier sub-agent. This sub-agent acts like a bouncer.
I like that analogy.
Its only job is to sit there, evaluate the risk of the main AI's intended shell commands, block the dangerous stuff, and let the safe commands pass through. It is literally AI keeping AI in check.
A local bouncer is great for shell commands, but we have to look at the ultimate high-stakes frontier where AI autonomy cannot be allowed to hallucinate biology.
Yeah, this is where the tension over open source versus closed models gets incredibly real. At OpenAI, and their president, Greg Brockman at GDB, just announced Rosalind Biodefense.
Yeah, this caused quite a stir.
It did. They are entirely restricting access to their new GPT Rosalind biology model. Only the U.S. government and heavily vetted allied partners get to use it for biodefense and pandemic preparedness.
If you look at the replies to Brockman's post, the open source community is furious.
They really are.
They are demanding open access to these biological reasoning capabilities to accelerate medical science. But OpenAI is practicing what they call defensive acceleration.
I have to agree with OpenAI here. Biology isn't software. If a coding AI hallucinates, a website crashes.
Right.
If a protein engineering AI hallucinates or worse, executes a malicious prompt, it could generate the recipe for a synthetic pathogen. You can't just open source a biological weapons generator and hope for the best.
No, you really can't. The friction between accelerating open science to cure diseases and locking down models to prevent synthetic bioterrorism is going to be the defining regulatory conflict of this decade.
Definitely. And if AI can now engineer proteins, parse 36-page documents in milliseconds, and autonomously review its own code, we have to look at what this means for human beings.
It changes everything.
Specifically, what happens to traditional education and the skills we use to navigate society. Mark Andressen at PMarca brought in a heavy critique from Casey Hanmer, a former NASA engineer.
Hanmer makes a really solid point here.
Hanmer argues that top U.S. university engineering grads are showing up to the workforce without core, independent problem-solving skills. He points out that rampant grade inflation has effectively destroyed the signaling value of the college degree.
The primary mechanism of the college degree was always a filtering system. It signaled to employers that a candidate could tolerate 4 years of complex, structured problem solving. But if an AI can generate a passing grade on a complex engineering exam in 3 seconds, the filter is fundamentally broken.
So what replaces it?
We're entering a paradigm where the degree is dead, And proof of work is the only metric that matters.
If you are sitting in a cubicle right now, assuming your Bachelor of Science is a permanent shield against obsolescence, this next part should terrify you. You cannot wave a piece of paper anymore. You have to point to a live system you actually built.
Absolutely.
Dravya Shah at Dravya Shah just launched Supermemory's company brain. This is an on-premise, Git-versioned universal knowledge system that connects natively to any AI agent.
And building a complex role-based integration like the company brain that is the new resume.
For the non-technical listener, what does Git-versioned actually mean in this context, and why is it so valuable?
Git is a version control system used by software developers. It tracks every single modification made to a code base over time.
Okay, so it's like a history log.
Exactly.
Yeah.
If a mistake is made, you can instantly roll back to a previous stable version. By creating a Git-versioned knowledge system for a company, you are building a perfect, indestructible historical ledger of every document, decision, and data point.
Oh, wow.
The AI can pull from this flawlessly without hallucinating. Building that infrastructure requires deep systems thinking, not just rote memorization.
So the premium is no longer on what you know, but on the infrastructure you can assemble. But this isn't just about engineering. We are watching the automation of creativity itself.
Yes, the creative space is getting completely disrupted.
At Min Choi shared a viral thread showcasing Google's Gemini Omni model. Users are executing hyper-complex video editing, transforming the lighting of a scene, replacing objects seamlessly, and even dictating the exact 3D flight path of a drone just by drawing a crude line on their screen and typing conversational prompts.
This represents the most critical shift in human capital in our lifetime.
It's wild to watch.
For the past 20 years, the economy heavily rewarded knowing how to use this software. The editor who spent 10,000 hours memorizing the arcane menus of Adobe Premiere, or the engineer who mastered complex CAD programs, commanded a massive salary.
Great.
That technical execution is now a rapidly depreciating commodity handled entirely by the model.
It's the difference between knowing how to swing a hammer and knowing how to design a house.
Precisely. We are moving into an economy that exclusively rewards knowing what to ask for. The premium shifts entirely to human taste, curation, and the ability to define a problem accurately.
But to know what to ask for, you actually have to possess a deep structural understanding of the world. You can't design a house if you don't understand the physical properties of gravity and load-bearing walls.
Exactly.
Which brings us to the most grounding piece of content today. Lex Fridman, at Lex Fridman, just dropped a podcast with Don Lincoln, a particle physicist at Fermilab.
This was such a fascinating conversation.
They don't talk about venture capital or AI benchmarks. They spent hours discussing dark energy, dark matter, the quantum vacuum, and why there is a fundamental imbalance between matter and antimatter in the universe.
It is the ultimate reality check.
It really is.
We are obsessing over WebAssembly parsing PDFs in 0.22 seconds.
Yeah.
We are hyperventilating over Anthropic hitting $1 trillion valuation and building literal magic wands with Gemini Omni. Yet, at a fundamental mechanical level, we still do not understand the laws governing the universe.
Yeah.
We literally do not understand the physics of empty space.
Our technological speed is blinding, but our fundamental ignorance of reality is still vast. To truly know what to ask these AI models to build, we have to actually understand the physical world we are building it in.
That is the ultimate bottleneck. The AI can only generate what we have the imagination and the physical understanding to prompt.
Which perfectly synthesizes the reality we've explored today. We are watching a real-time decoupling. The speed of private capital and the brute force of localized hardware are completely breaking away from our traditional structures.
Yes, the old rules don't apply.
The regulatory frameworks are producing laughable $200 fines for massive capital movements. The university degree is losing its weight as a proxy for competence.
If you're looking for a sharp prediction on how to position yourself for tomorrow, look at it this way. Watch the venture capital flows over the next 6 months.
What are we looking for?
As NVIDIA pushes these highly efficient ARM-based chips and open source models prioritize intelligence per watt, the smart money is going to pivot.
Away from the cloud models.
Yes. Venture capital will quietly shift away from the exhaustingly expensive multi-billion-dollar race to build godlike AGI in the cloud. Instead, you're going to see a flood of capital pouring into hyperlocal, on-device enterprise agents.
The open Jarvis type of stuff.
Exactly. These will be systems that run natively on the new PCs sitting on your desk, executing your company's proprietary work without ever sending a single byte of data back to a centralized server. The era of the cloud monopoly is cracking.
Which leaves you with one vital question to consider as you navigate this shifting landscape. If AI agents are now autonomously acting as bouncers for their own code, if a prestigious college degree no longer proves your competence to an employer, and if technical execution is completely commoditized, what is the single, unautomatable skill you need to be cultivating in your own life right now? Think about that. Thank you so much for joining us, and we'll see you next time on the Daily Vibecasting.